It is my great pleasure to bring a good friend of mine on to the stage to round out this incredible day. Mr. Ciro, where you at, bro?
Can you see me?
Yeah, how you doing, dude?
Hey, guys. I'm pretty good. How about you?
I'm great. It's awesome to have you here. Let me turn this music down so you can get rocking and rolling.
Can you see the presentation?
I can see it, but I don't see it on the stage yet. I'm going to bring it up right now. Just give me a second. How about that?
Beautiful. Okay. That sounds good, man.
Brilliant.
Well, thank you very much for having me. We're going to talk a little bit about data as software and what we call the programmable lakehouse, which in practice means we're going to talk a lot about AI. And it's a good segue from the previous, I think, talk. A little bit about me. I spent a lot of time doing machine learning and AI and building infrastructure to support those use cases. Built a company was doing NLP, NML for recommender systems and search. Got acquired, led AI from scale up to IPO at Cavell. And like my team and I kind of like built a lot of systems from the perspective of having data heavy workflows and models embedded inside of software applications, like a recommender system or a search engine, like something that is out there and there's a user that tampers with it in production. And a lot of that boils down to what I'm doing today. The co-founder and CEO of a company named Botlan. Botlan is essentially a Pythonic data platform, and we focus a lot on data transformation and AI workloads. We help essentially developers to bring to build applications very quickly on their data and very seamlessly. We help them by abstracting away the infrastructure. So all the compute provisioning and configuration, all the containerization, the environment management. So that's why it is as a serverless, completely serverless. We help them by bringing very simple code first abstractions, because that is a very good way then to incorporate those workflows then in a software application. And we build an S3 because we believe that the separation between compute and storage is here to stay. We're very excited about what is happening in the data lake and lakehouse space. We're going to talk mostly about AI and how to build AI to fruition. And if I have to summarize what AI looks like today, is essentially data plus code. And what I mean by that is that one of the biggest differences between AI 5 years ago and AI today is that, of course, like you have pre-trained models, and pre-trained models make available this incredible inferential capabilities through just like an API call. And that has a bunch of like consequences. The first one is that more software engineers are able now to access those capabilities and bring that intelligence inside of software applications. So there's a broader range of developers, which is very exciting for organizations that want to see more ROI from their AI initiatives, because there's literally more developers that can do that. And the other one is that also your applications are going to look like a little bit more like software applications, because it's an API, and so the workflow and the kind of like end-to-end life cycle of your applications now embeds these capabilities, but it looks a lot like a more traditional software engineering life cycle. And one of the main points that I want to make today is that AI is essentially pushing data into software. And companies need more and more software engineering friendly platforms, abstractions, and tools. And a lot of that boils down to be very code first and code oriented, so that developers can work more easily. Now, code means effectively means Python for this thing, because Python is historically the lingua franca for data scientists and machine learning people. There's a lot of great support that comes from the history of Python, and right now is, according to GitHub, is the most widespread language, and it's growing like crazy. And clearly, that is driven by AI. So, like, also for people who run organizations, keep an eye on your Python workloads, because the importance of those workloads will change radically to compared to what you're used to in the next few years. So the bottom line of that is that you want to have then basically ways for developers to access these capabilities as simple as possible and write their code against your data. So the question that remains open is what it means to bring data into the mix. Because AI became radically simpler thanks to pre-trained models, data kind of, like, it depends. Like, there's still a lot of fragmentation and complexity. A good place to start for data for use cases, for AI use cases, is usually object storage. That again has historical reasons. There are, that's where your unstructured data used to live. The image that you see now on the screen is a reference implementation that AWS advised developers to follow, and this is a very familiar kind of workflow. If you did data science, you have some data in a tree, some files in a tree, and you're going to read those files into a pandas data frame. You do your thing, and then you save your result as another file in a tree, right? Now, this has been like historically the way to do things. So developers in AI are well versed in object storage. It hasn't been necessarily a very good way to do things, though, because like when you want to do things like at scale and more systematically, files are not great. What about schema evolution? What about transactions? What about performances? Because clearly there are better ways to process data than reading an entire file into the memory of my process and just like turning it into a pandas data frame and save another file, which you see as takes a toll, especially when you work like with large scale data sets. And what about versioning, which is a very important capability that you want to have in your stack, because it's so important when you do AI and ML to be able to iterate quickly on different versions of models and data sets. So object storage, great, not so great up until now, but that's where what happens nowadays in data lakes is so exciting for us. Open table formats really come to the rescue, bringing a lot of capabilities that were usually just like in the warehouse world to the data lakes. Schema evolution, all three major open table formats supports just schema evolution. So I don't have the developer now interacts with a higher level abstraction, which is a table, which is a much more intuitive abstraction, and it's easier for us to keep track of what happens, and we don't really need to know what happens at the file level, which is a bit too low in the stack to reason cleanly about. Um, Performances are a great improvement because like instead of just like reading an entire file in the memory of my process, I can now say I want these columns, and the system now provides a higher level abstraction, as I was saying, and the system now can query and just access only the data that corresponded to certain columns, to certain filters. So I can do a lot of push down against object storage, which has 100x improvements, especially if you work on large data sets. And versioning is another very important thing, as I was saying, is particularly important because, like, if I have to single out one thing that your machine learning and your AI team needs to do to be very effective is fail fast. You're going to, train a model, fine tune a model, just try a model against a certain data set. You get very quickly to the point that you get a result is not quite what you want. You want to iterate on that and maybe change something in your data, change something in your model, both. And you kind of like progressively walk your way to where you want to be, which is great. And also is the kind of thing that never ends because like data will keep changing. So this progressive like approximation to the optimal solution is something that a machine learning team and an AI team that basically never stops doing. It's very important that you have good ways and clean ways to version your data sets and your models, and think a little bit about that like you would think about branches. I have my data set, I run a model against that in one branch, I save those results somewhere, and now I open another branch and I do that again with a different model or with a different data set or both, and so on. And again, like all the major open table formats do support these capabilities, which is very exciting. So if you wanted to kind of like wrap up like the takeaway message around what you should do to make very easy for your organization to get AI basically in production in real use cases that are part of applications that bring value to users. You want to have a lakehouse. So you want to have like your data stack built on object storage plus open formats. And you want to make sure that your developers can develop directly in Python. And SQL maintains like a very important role in special aggregation. But ultimately, your kind of like lingua franca will be Python for all those applications that you build with AI, RAG, recommender systems, chat, agents, a lot of data pipelines that do data augmentation or synthetic data generations and so on. So it's a matter of bringing the lake, like Python and the lakehouse, like as close as possible, as efficiently as possible. Now, running Python in the cloud has historically been pretty complicated. We're not going to talk about that. There's a lot of work that we did about Python on that, but like we're not talking about that. Let's talk about like more about, so I'm a Python developer. How do you bring the lakehouse to me? Like, how do you make it easy for me to just like access those abstractions and work with the data that are, you know, somewhere in a data catalog in my object storage? One very important point that I want to make here is that to make things effective in an organization, it's very important that people and teams can work together on shared abstractions, and you minimize the silos and you minimize the amount of effort that you need to go from one phase to another, from prototype to production to, you know, higher scale and so on. When you build up software applications, you need a little bit of everybody. You need data scientists and data engineers doing like the business logic. You need software engineers managing the applications. You need DevOps to manage like the reliability and robustness of your life cycle. These folks will share one thing that is code. What they don't share, on the other hand, is infrastructure. So the abstractions of the code can be made in a way that different tribes in your organization can share abstractions as much as possible. The more infrastructure you bring into the mix, the more you're going to create silos. So essentially what you want to do here is abstract away as much infrastructure as you can and really piggyback on abstractions that every developer understands. Like make an effort, a conscious and constant effort in making things as simple as possible. If it's not already familiar to a developer, an abstraction needs a justification in your system. So I'll give you like a very practical example of this. Like, let's say that I have a lakehouse, so I have a data catalog on top of my object storage, and I have some tables there, and I want to start like building my application, and I want to do that in Python. So I want to take some data from that data lakehouse, and I want to process and write something back into the lakehouse, right? One very good way of thinking about this is like, what are the things that everybody knows, and what are the things that I should not take for granted? For instance, not every developer knows necessarily what containers are. Not every developer certainly knows what containers are in your specific organization, like how you manage that and how you decided to organize that. But every developer understands what a package is. So a good way to abstract that away is, why don't we allow developers to declare directly in the code what packages they need, and then the system figures out how to create a container and run that in an isolated fashion in the cloud for them. The other thing is data. I have my process. I need to get data from my data lakehouse inside of my process and do something. Not every developer knows what a data lake is. Not every developer is super familiar with Parquet or Iceberg or Hudi or Hive. But every person on earth knows what a table is. It's just a schema, a bunch of rows, and a bunch of columns. And the system should abstract away all the way in which this table is actually implemented in your data lake. We don't care whether this is an Iceberg or a Hudi table. What we care about is that we can declaratively express that in my code in the way that you see on this slide. This is just a bunch of columns and filters. The system should figure out how to fetch the data that correspond to this table in whatever implementation your system supports. And finally, running things in the cloud is also challenging depending on your layer of the level of abstraction. Not every developer knows how to, deal with Kubernetes or super familiar with Spark. But every Python developer on Earth will know how to do functions because that's literally what you do in Python. You write functions. So if you do something like this, every developer in your organization will be able to master the major abstraction that your system has. The same goes for your data management. Not everyone knows how to version data or to keep track of that or to, use the open format tables, open table formats to do that. But every developer is very familiar with systems like Git. So the abstraction that we want to expose to them should, again, leverage the fact that these concepts are very clear in their mind. So if you look at the snippet of code on this slide, even if you never used the system and you never saw this in your life, it's pretty easy to understand what this snippet of code does. And that's really what you want to do. This creates a branch, you put your data in a branch, you run now in a sandbox. Something goes wrong, you want to roll back with a notion of a commit, which is very familiar to everybody. If everything goes well, you can branch it, you can merge it into your main data lake. Again, it's easy to understand what this snippet of code does. And it boils down to that, to how simple your system should be and how little your developers should care about the implementational detail. When you bring this kind of simplicity in large enterprises, which is the final point I want to make, this gets like very powerful. One of the largest companies that we work with is a fairly complicated organization because Mediaset is one of the largest broadcasters in the world, and they operate clearly at a very large scale. They have petabytes of data and billions of events and millions of users. So there's a lot of developers, a lot of different teams, a lot of different tooling. If you bring a system that really is code first and is abstracts away infrastructure and is based on things that everybody somehow can easily understand, what you get is this nice progression that goes from one team that starts using the system, maybe data scientists, and they do something simple, maybe analytics. And then that team gets to the point that they build more things, and now they can pass it over to data engineers to go to production. And then we start doing something more complex, like ML. And now we have two teams and two use cases. And then finally, when you're really ready, we want to put this on a large scale in production. This is a large organization with large applications. So now you need DevOps. And now DevOps came into the mix, and you have automation. And now you can do like more complicated use cases. And you really have this progression that goes across the different teams in your organization. And you can get like 10x faster in bringing to production more use cases because more developers can basically work on the same concepts. If I have to wrap up this, is basically that I think AI is turning data into software, and more we need software engineering friendly platforms, which for data means code first platforms, which are not very common out there. If you're doing AI, Lakehouse plus Python is probably the best way for you to get like more ROI, as much ROI as possible. Branching and versioning is super important, and I cannot stress this enough. Good APIs, good APIs, good APIs. Keep it simple, keep it easy, and every developer in an organization can work on the data, which really unlocks the next level kind of productivity. If you want to reach out, I'm always here.
I want to reach out. That was a very articulated conversation, very clear, very easy to follow. I appreciate you so much, man. Thank you for closing out the day with us. I'm excited for when we get to hang out again soon, hopefully.
Fantastic. Always.
And I'm going to serenade you before we go because that's it, man. We closed off the official sessions. We've got a workshop happening now, but I'm going to give some closing words, aka a closing song for everybody. And just in case you're sticking around and you're wondering, wow, how can I tell these people how much I loved this event? Go ahead, scan that QR code. We got a feedback form. You can let us know what you liked, what you did not like, all that good stuff. Now, Ciro, let's tell these people, come on. Don't let me down.
The falsetto, I appreciate that.
Don't let me down. Scan that code, don't let me down. So if y'all are looking for a little more session, we've got it coming up. Ciro, this was awesome, bro. There's a few questions that came through in the chat. We don't have time to answer them, but if you want to jump in, I'll give you a link right now.
Yeah,
always a pleasure.
Cheers, man.